Hello, good evening all.
Good evening, sir.
Yeah, you can start in a couple of minutes. Yeah, so once again, a very good evening. We'll start the session now. Yeah, so before proceeding, I'll give a small revision, okay, and then you can ask the doubts, and then you can proceed. Okay, so now, yeah, we started with data structures in the last class, and we saw the advantages of data structures. Why should we do a proper data structuring? Okay, so it is just to like speed the access. Okay, so like retrieval time should be reduced, whatever might be the data. Okay, and we saw the four major operations done on any data given is this CRUD operations: create, read, update, and delete. Okay, and then these are the different data structures which are available, and then we have something called the storage structures which are used to implement, okay, in real time in the programming world. Okay, these are all concepts: list, stack, queue, trees, graphs are all this one concepts. Okay, to make it real time we use something called storage structures, and we saw the first okay, the linked list implementation of the list data structure, and we saw the various operations that are performed on a linked list. These are the various operations that are performed, and we saw this yn, this is yes or no. Okay, which means that which all operations need and change in the head value in a linked list. Okay, so append, added beginning, added position, and delete, these three operations, all these need a change in the head value, and wherever I marked as no doesn't need a change in the head value. Okay, and then now we have this linked list class, and this is a node class. Every node, okay, every node is every data. Okay, a node contains data in the link part. Okay, so we store the data as well as the address of the next link. Okay, next node, address of the next node, both are stored in a structure called as node. Okay, and then we have the linked list. Inside the linked list we have only one value, which is the head value, and the purpose of head is to store the address of the first node. That's it. Okay, so only thing of the head is going to do is store the address of the first node. And we saw the append function. Okay, in the append function what do we do? Yeah, we also saw this memory structure, how all these are getting added. So in append function, first what we do is, and these are the steps which were followed. First, we need to create a node and then fill the node with data and link, and then link it to the existing linked list. Okay. And we need to traverse, right? So append means what? We're going to add a node at the end of the linked list. Okay, there might be any number of nodes in the linked list. Append means you're going to add a node at the end of the linked list. Okay. So for that, what we have to do is we need to go and search of the last node. Okay. So only if we know the last node, then we'll be able to add the, or we'll be able to change the link of the last node and then make it point to the new node. Okay. Yeah. So actually there are two scenarios over here for append. So one is, okay, the if condition where the head value changes. Okay. So if the linked list is empty, what happens? You will create a new node and then assign the address of the new node to the head. Okay, that is the only scenario where the head value changes. And the else part, what we do is we just iterate through the entire linked list and reach the last node. And this is the condition for going to the last node. And once we reach the last node, we come out of this loop and then simply assign the new node to temp of link. Okay, this is what happens in append. Add at beginning, what happens? Every time a new node will be added at the front. Okay, added to the head. So the head value changes every time you insert a new node at the beginning, right? So now what we do, we just make the new node point to the existing first node. Okay, that is what is happening over here. And then make the head point to the new node. Okay. And this is what we saw with respect to the coding part. We also saw how the other things are working using the memory. Yeah, so this is a quick summary. You can, if you have any doubts, you can ask. Have you tried these functions? Have you traced it and saw? Have you worked out in a notebook? Any doubts you faced while doing any of these functions? Yes. No one tried? Okay, any doubts? If you have doubts, you can ask me, else we can move to the next concept. Yes, please, I want someone to speak because it is totally new, right?
So actually,
Yeah.
I was absent for the last class. I don't know much about this. So I'll just see and again I'll ask.
Oh, there are 4 days, right? You could have seen in these 4 days.
But didn't see.
Okay. Is anyone else?
Sir, I wasn't able to code it.
You were able to code or you were not able to code?
No, I won't able to code it.
No, I didn't get you.
Sir, I wasn't able to code. I understood the concept that how we can add it
Okay.
at a position or after the position. But when I tried converting that logic into code, it wasn't working.
Okay. Which function you tried and what was the like?
Sir, in the proper function which we make now while adding at the position.
Adding at the position. Okay.
Yeah.
Okay. So okay, you can see. What did you try in adding at the position? How did you do?
So 1 second, I'm opening my code.
Okay.
Sir, I tried to search for the position first,
Okay.
and then sir, the argument will be self comma data.
Arguments are self comma data. And what about position?
Okay, yeah, and the position.
You didn't pass the position.
I forgot.
How can you forget the position?
Yeah, but sir,
Hmm.
okay, for this one it's okay, but still, when I sometimes I try to convert the logic into the program, I
Hmm.
face that problem. How can I work upon it?
I don't have an answer. Only practice. You have to
Okay,
understand how the compiler is working, how the loop is working. You have to have the flow in your mind. Then only, and if any error comes, like either the compiler says or some logical mistake would be there. You should be able to trace the code.
okay.
Okay, you want to try this?
I'll try it once again.
Now only you try. Tell me.
Okay. So then, if we have to add it at a particular position,
Hmm.
we have to pass the position, and
Hmm.
then we'll create one more node with the address where
Hmm.
we will store the data that has to be added, and
Okay.
I think
No,
we
wait,
will
wait, wait,
change the head
wait.
value.
1 second, wait, wait, wait. If you tell one step, quickly tell the implementation as well, so that we can do it step by step. First, you're creating a node, right?
Yeah, we are creating a node.
Okay. Tell me the step for creating a node.
NN is equals to node underscore s,
Hmm.
and that value and head, self dot head.
Why self dot head? We're not sure where we'll be inserting, right?
Yeah.
So, like, let us leave it as it is. Just
Okay.
data. Okay. Then,
Then once the node is created, we
hmm.
will search for the position.
Is there any special condition? Why
Uh,
is it marked yes or no here? It is marked yes, right?
yeah.
So it means there's a scenario where head value changes.
Yeah.
So what is that?
If the position is in at the beginning,
Yeah, means position is equal to
0 or head value.
no position is starting from 1.
The position is 1.
Yeah. So tell me the condition if
Position
Uh,
greater.
hmm,
position
POS is equals to
1. Hmm.
yeah.
Yeah. So
Then
now, uh,
add at beginning.
so like yeah, we cannot call add at beginning, right? So we can write the steps here itself.
Okay.
You want
And
to call add
then
at beginning or
yeah, can we call add at beginning?
uh,
We
actually yes.
can call a function from a function, no?
Yeah, we can call, but again it is inside the class. Mm, mm. Yeah, we can call, but you have already created a node here, right? If you
Yeah.
call add at beginning, one more node would be created.
Okay. Then
So just manipulate this node. Node is created.
hmm.
So
So
what should nodes new nodes link point to?
the head
Yes. So nn dot
head
no link is equal to
self
self dot
dot.
head.
Okay.
So, okay, let us do it in the Excel as well. See here position is 1. So they have a special condition, and then suppose this is the data to be inserted. Okay, and see let us first see how the data is going. First 5 and then 2160. This is the second node 15, 2163, third node 20, and this is the fourth node, this is the fifth node. Okay, and yeah, you can just forget about this node, and this is a node that has to be, this is a new node. Okay,
Yeah.
position is 1. So now what you have to do, what should this point to? New nodes link should be pointing to, so I think we did add at beginning, that's right. Okay, so 2157 was head, right?
Yeah.
So head is pointing to 5. Okay, so now I
Yeah.
want this link to, this link should point to 5, that is this first node. So what should
Yeah.
I put over here?
The address 2160.
No,
No, 2158.
57.
57. Yeah.
Yeah, so that is where is that value stored? In head, right?
Hmm.
So this one, nn dot link equal to self dot head. So now this will become 2157, which is nothing but this node is pointing to 5. So we have created a link between the new node and the already existing first node.
Yeah.
Now we should make head point to new node.
New node.
So what should head become now?
3160.
Yeah, so what should we assign head to?
New node dot link.
Why new node dot link? New node dot link means it start pointing over here, right? New node itself,
Okay.
see, new node is only 3160, right?
Yeah.
So it is self dot head is equal to new node. That's all.
Yeah.
Okay, so now else part.
Then we have to check for the position.
Yeah,
Like
but
at which position we have to add.
okay, suppose 1 2 3 4 5 6 nodes are there, and then I want to add it position 4.
Yeah.
Okay, and then the new node is 3156, and suppose this is 40. So I don't have anything in the link. Let me remove the link part. Data part is 40, and then I want to insert it position 4.
Yeah.
So between which and which nodes this 40 should be inserted? Question is 4.
So between 20 and 25.
Is it 1 2
Acha.
3? No, this is the first node. 45 is the first node.
But
5
sir, the 45 was the case if we have to add at beginning, no?
no, see, we have already changed, right? So instead of changing it again, let us assume this is the first node.
Okay.
45 is the first node, 5 is the
Then
second.
between 15 and 20.
Yeah, okay. So between 15 and 20, 40 should be inserted.
Yeah.
So what are the changes? So what should this node point to?
This should point to the address of 20, which is 2163.
Yeah, correct. So here 2163. Okay, and then
15 should point to 3157.
3156. Okay.
56. Yeah.
So first we need to reach this node 15, right?
Yeah.
So in the existing linked list, only the node 15 is 15's link is changed. Okay, so we need 15's address. So
Yeah.
how to get 15's address? How many times should I iterate to reach 15?
3.
No.
Position -2.
Yeah. So 2 only. No?
Yeah. Yeah.
So initially we are at 3160. If I iterate once, I get 2157, which is 5. And if I iterate the second time, I get 2160, which is 15. That's it.
Yeah.
So I should iterate position
2
minus.
times. Yeah, 2 times.
So tell me the loop for iterating position minus 2 times?
So while we'll
While
link
see, we need a temporary variable. Why do
yeah,
we? So because we are iterating, right? So we need a temporary variable. We cannot use head for iterating. Why?
because head will change.
What happens if head changes?
If head changes, the list will change, no?
Mm, list. Okay. Linked list is irreversible. You cannot go back. That's why.
We cannot go back and
Yeah. Linked
get
list will
the
be lost.
previous head.
Okay. So temp equal to self dot head. So while what is the condition?
Temp dot nn dot link is equal to temp dot link.
Hmm? No condition. I'm asking. What is the condition? Till which point I should iterate?
Position minus 2. That
Position.
is yeah, we want position also, no sir?
Position is already there. Okay. So we need a temporary variable to check whether it is reaching position or not. Okay. I less than position minus 2. Okay, we can also put it in a for loop, no problem. Okay, so I equal to 0 while I less than position minus 2. So this loop will iterate position minus 2 times. Okay, so what should I do now? Temp is equal to, I should keep on jumping to the next nodes. Okay,
Yeah.
temp equal to temp dot link. Okay, so we have to add more constraints. We'll come to that later because I told you one more condition, right? Suppose there are how many nodes are there? 6 nodes are there, right? If I give 10 as the position, then what happens? Once
It should print that number of nodes is less than n.
number of yeah, less than the position, right? So that warning should be printed. So we'll come to that later. Now I have iterated position minus 2 times. Okay. Now what should I do? I have reached temp. I have reached this 15. So temp will
Yeah.
be storing 2160. So using
Yeah.
temp, I can do these changes. I should,
Yeah. So nn dot link is equals to temp dot link.
yeah, very good. Okay, then
Temp dot link is equals to nn.
equal to n. That's all. Okay, so this will add at a particular position. Now let us check. Okay, so I added 4 elements. Let me add 2 more elements. Okay, before that, let us write the display function to see. So we can write the str method. Def str. So in str method, we need to create a string. Okay, so we can format that string and then return. Like I'm just going to print all the nodes. Okay, so data of the nodes. That's it. So I just create an empty string and then I should iterate over this linked list. Right. Again, I cannot use the head value for iterating. I create a temp value self dot head. Okay, and then till temp becomes null, I keep on iterating. And I just append the data part to this string. Okay, yes. So yes plus is equal to str of temp dot data. So because data is integer, right? Okay, so I'm converting it to a string and then appending it to yes. And along with that, I'm appending a space. Yeah, that's all. Return yes. So if I just print ll, the str method would be called, and then we'll get the output. Okay. Now next, let me add at position. Okay, 1 to 4th position. I want to add. Okay, 5th position. I want to add 30. Okay, added position. First, I have to pass the data, which is 30, and then position is 5. So first node, second node, third node, fourth node. 25 is the fourth node, and 30 should become the fifth node, and 35 sixth node, and 45 seventh node. Okay, print of ll. Okay, it is an infinite loop. Why? Because see, I haven't moved the temp value to the next node. Okay, temp equal to temp dot link. Temp reaches none, temp not equal to none.
So I think it's null or none.
None only. In Python, it is none only.
Okay.
Okay. 2, 2, 4.
Maybe it's storing none in temp and then accessing data.
Okay, here it's a mistake. Here also I should make a I should increment I, right? See, that's what in loop means it should contain I, C, and U, right? U is missing. Initialization, condition, updation is missing. So I plus equal to 1. Sorry for that. Yeah. So fine, the node got added at 5th position. Okay. Now coming to the special condition where if I give 10, position as 10, okay, it should throw an error, right? So what should I do over here? Yes.
It should be equal to the length of the list.
Yeah, but again, to find the length of the list, then I have to put a loop, right? A separate loop should be written. Yeah, that is also correct. We can just write a loop and then check the length of number of elements. And then if the position is like less than the number of elements, then it should throw error. I mean, position is greater than number of elements and it should throw error. That is also fine. Instead, simply what we can do is we can like while iterating in this loop itself, we can check whether temp is reaching none.
Yeah.
Okay, if temp is equal to none, break. Okay, and once I come out of this loop, if temp is equal to none, then it means that the position is crossing the number of limits, number of elements, right? So if temp is equal to none, print position is greater than number of elements. And then else. Okay. See, now there are how many elements? 7 elements are there. Okay, let me insert one more element between 35 and 45. I'll insert 40. So what should be the position that should I give?
7th position.
Yeah, ll dot added position of 40 comma 7 print ll. Okay, now how many elements would be there? 8 elements would be there. Okay, now ll dot add position of 50 comma 10. Okay, so 40 is added. If I give 10, then it is telling that okay, position is greater than the number of elements. Okay, so there are 8 elements, right? So if I give the position as 9, it should work. Okay, so these are all boundary test cases. You should be very careful. So one boundary test case was adding at the beginning. Okay, 0th position. That is the first position. So if I give the last position, then that also should work, right? So let us check whether our code is working for that condition. So ll dot add position of 50 comma 9 print ll. Yes. So for all conditions, it is working. So now let us try for position 1. So that we haven't tried. ll dot added position of 1 comma 1. Yes. So for all positions, it is working. Fine. So this is how you should convert the logic into code. Okay.
Yes, sir.
So now will you be able to try for other logics?
Yes, sir. We'll try.
Okay, so this would be a little bit difficult. Let us try for this. Add in ascending order. Anyone wants to try?
Yes, sir.
Okay, then you can only help me now. So
Sir, if the linked list is not sorted, we have to sort it first now, or
okay.
it's okay. Anyways, we can add.
No. Yeah, correct. So let us write a fresh code. That should be only added ascending order. We just comment this and write a fresh code. So node class is same. We can take that. Linked list. Now, okay, we can come to main program later. So def add in ascending of. So we need to pass just the data, right? What all you need to pass?
Yes, sir. Only data.
Okay, fine. Now, what is the basic idea? We'll just discuss in this memory first, then we'll come there. This gives a clear idea. Okay, this is the initial stage. Okay, now I have NN and NN is 2184. Fine. Now, so suppose data is 5. Link what? Let it be empty as of now. No, this is the first node, right? So what should I know? What should I do?
Change the head value to the data dot link as in 2184.
Oh, 2184. Yeah, correct. Why data dot link is just NN, right?
Yeah. So data dot link gives the link value of that node.
No, data is an integer. We cannot take a link for data.
Okay.
Only for NN. NN dot link gives this particular position.
Okay. Understood. Yeah. So we have to change the head value to NN.
Okay. And then what should link be?
None.
Yes, very good. So this happens while creating the node itself. So we need not worry about assigning none to none over here. So like we are creating a new node. NN is equal to
Node underscore S data.
node underscore s of data.
Data.
Okay. And then, so if head is equal to none, we have to change it, right? So
Yeah.
if self dot head is equal to none. Okay, if self dot head is equal to none, what should we do?
NN self dot head is equals to NN.
Hmm. Good. And then no, so first node done. Okay, now let us add. Now the other condition where the head value changes is if we add the node which is the smallest node, smallest with the smallest value.
at
Okay,
the
all
beginning.
yeah. So like just create one more node where the data is
1.
3. Okay, okay, 3,
Yeah.
1. Yeah, so now new node is 2187.
2187. Head will be NN.
Head will be NN. So no, should head, what change we have to make first?
We
Should
have
change
to
do we need to change the head first or no, right?
first. Okay, then first we will change the node positions, as in we'll swap it, and then we'll change the head position. Or
See, there can be any number of elements. It's not only element. There can be 5, 10, 20 like that. Any number of elements could be there. It's not the only one element present. We cannot simply swap.
no, I mean here just 2. That's why I said so.
No, we need to just like play with the link value. That's it.
So okay, NN dot link will become
Hmm.
2184
Yeah. From where should we take 2184?
from the 5 link, the first
No.
node 1 link.
Yeah. No, not link. What is head?
Yeah, 2184.
So from head itself we can take, right?
Yeah.
So from head we are taking the value and storing it in nn dot link. Okay. So what is the condition? So how will we know that you're going to add at the beginning?
If the data value is small,
Yeah, tell me as a statement. Python condition.
okay. Else
Hmm.
data self dot data.
It's not self the data. Okay, so now we have come to know that linked list is not empty, right? There is at least one node. Okay.
Yeah.
So now what you have to do is you have to check whether head's data. Head is nothing but the first element, right? First node, right? So the first node's data, if it is less than the new node data, then we have to insert the new node at the beginning
Yeah. So how will we get the heads data?
using head only.
Head dot
Self
data.
self dot head dot data. That's all.
Oh,
Hmm. Self dot head dot data
is
is, sorry, if it
equal
is less than
less than NN dot data.
nn dot data, or directly you can put data because data also same, right?
Yeah.
Okay. Now what?
Now, if it is less than that, then we will be adding at the first position.
Hmm.
So NN dot link will be head.
Okay. 2184. So nn dot link is equal to
Head.
self dot head. Okay. Done.
Okay.
This is done. Then
Yeah.
what about head?
Head will become 2187.
Hmm. From where should we take 2187?
NN
Yes. So self dot
dot head
equals what?
NN.
Yeah. Good.
So basically self dot head will give the value of head.
Value of head is nothing but the first node
The
address.
first node link.
Yeah, not link, address.
Yeah,
Like,
sorry, the address of the first node.
yeah, correct. It is actually pointing to the first node.
Yeah.
Okay. Now this special condition is done where we have to insert um, what at the beginning. Okay.
Hmm.
Now let us insert what 3. Okay. NN is 2190. Link what? I'm just removing it. Yeah. So now what should I do?
The 3 will be inserted between 1 and 5.
Hmm.
So we will check if NN
Hmm.
or if the data is less than
Hmm.
the new, as in, so basically we will be checking.
Yeah, we have to put a condition.
Yeah, if the data is greater than the node 1's data, then we'll go to the second position. If it is still greater than that, then we'll go to the third position. So a temporary variable can be created.
Yes, we need to iterate, so we need a temporary variable. So where to stop the iteration? That is the question.
When the data becomes less than uh,
Hmm.
less than the element in the list.
The temps element, right?
Yeah,
Okay, while data
is greater than
greater than
self dot temp
temp dot
dot,
data.
yeah, which is self dot head dot data, right? If I'm not wrong.
No, again, see, self dot data means it's just the first node, right? How will I check for the second node, third node, and all? I cannot change the head value. That's why I have taken a temp.
Yeah, yeah, yeah.
Okay. So temp dot data. Hmm. If it is greater than temp dot data, I have to move to the next node.
Next node. So I will be initializing
No, temp is equal to
temp dot link.
yeah. Temp is equal to temp dot link. Okay, so now let us see. Let us do this iteration and see what happens. What will be the value of temp once it comes out of the while loop? Okay, then only we can we can further proceed. So initially there are two nodes. Head is 2184. Sorry, it is 2187, right? So this is the first node. Okay, and this is the second node. See, first node is 2187. Data is 1. Link is 2184. So this is 2184, right? 5 is the second node. And this is also the last node. So it is none. So now I should insert this 3 in between 1 and 2. Okay, so let us see after the execution of while loop where does temp stop. So initially temp value is 2187, not 2184. Okay. So now, okay, so where is the change happening? Is it happening at 2187's link or 2184's link?
2187's link.
Yeah, correct. So I'm changing the link of 2187. So I want 2187, right? I want 2187. I don't want 2184. I should not stop at 2184. Whereas I should stop at 2187 itself. Now let us see what is happening to temp. Is it stopping at 2187 or is it stopping at 2184? That is what we need to check. Okay, so initially temp is 2187. What about the condition? Condition is data greater than temp of data. So data is what? 3. Okay, it is greater than temp dot data. 2187 data 1. Condition is true. So now what happens? Temp equal to temp dot link. So temp value changes to 2184. Now temp is pointing to 5. Okay, this node. Now what is the condition? Data greater than temp dot data. So data is 3. Okay, so we can data 3. Okay, so data is 3 greater than temp dot data 2184 data 5. The condition is false, right? So it comes out of the while loop. Now the temp value is 2184. It is not 2187, right? So what should I do? I want 2187, not 2184. Yes. Okay.
Then we will not initialize temp is equals to temp dot link,
Hmm?
but we will need to do that because if the second, if we don't want to add it between 1 and 2, then we'll need the link of
Yeah.
the second node, na?
No, I'm asking any other alternate things, any alternate procedure is there. So this is taking me to the next node. I want the
Yeah.
previous node. I want the previous node. So one thing we can do, two things we can do actually. One is like we can have a previous value. Okay, previous is another pointer. Okay, which will store the node's address. Okay, initially I'm marking it as none. So before changing the value of temp, I'll just store it in previous. Okay. Now let us see what happens. Previous, which is initially none. Okay. So now temp value is, now let us iterate it again. Okay. I've initialized temp as 2187, right? Head value. So it is pointing to data 1. While condition data greater than temp dot data. Data is 3 greater than temp dot data 1. Condition is true. Okay. What happens? It comes inside the while loop. Previous is equal to temp. The first statement. So what will happen to previous? 2187. Right? Now temp value is also changing, right? Temp is equal to temp dot link. So temp dot link is 2184. So temp changes to 2184. Now again the condition, data greater than temp dot data. Data is 3, temp dot data is 5. So 3 greater than 5, condition is false. So it comes out of the while loop. Okay. Once it comes out of the while loop, we can see that temp is carrying 2184, whereas previous is holding 2187. That is a node which I need, right? Understood?
Yes, sir.
So now using this previous value, I can do the changes. Okay. So previous, what should I do? So first, so what should I do? I have the new node here. So new node's link should point to where?
Temp dot link.
See, is it temp dot link or temp itself?
Temp's link.
Temp's link is none, right? See, I want 3 to point to 5.
Yeah, correct.
Okay, so either I can do previous dot link or just temp. Both are same. Previous is 2187, right? 2187's link is also 2184. Temp is also 2184. So either I can put previous dot link or temp. Both would work.
Yeah.
So nn dot link is equal to previous dot link. Okay, you can also put temp over here. Both are same. Now second, now this is 2184, right? Now I want previous to point to new node. So what's the step? Previous dot, yes,
Link.
yeah, is equal to,
You have to point it to new node, na? And then
That's all. Okay. So this code will work if at some point, okay, data becomes less than any of the elements in the linked list. Okay, suppose if I give an element which is greater than all the elements. Okay, suppose if I give 10. Okay, so now what happens? This while condition will never become false, right? At one point, temp will reach none. If temp reaches none, and if I try to put temp.link, at that time error will occur. Okay, fine. Now what we have to do? We have to check whether temp is reaching none or not. If it is reaching none, okay, it directly means that you're going to append. Understood? So I'm going to write one more condition here. That's it. If temp is equal to none, break. Okay. So now let us have this code and then try inserting node 8. Eight or 10. Okay, 8 itself is fine. Now let us see. Data is 8. Previous is initially none. Are you able to follow? Any doubts? Anyone? New node is 2193. And then temp is 2187. So all the initializations I have done, and I have created the new node. Data is 8, and then link. Okay, I should still I should know what should link store. Once I iterate, then only I will know. And the data is 8. Okay, the new data which going to insert is 8. Fine. So like so this is the first node. Okay, to this. Okay, this should point to where 2190, right? So first node, second node, and this is the third node. You can just refer the links. So head is 2187, is pointing to 1. So one's link is 2190, which is pointing to 3. 3's link is 2184, which is pointing to 5. And 5's link is none. Okay. Now, let us insert 8. So 8 should be inserted where? Yes. Where should 8 be inserted?
at the end.
At the end. That is after 5.
Yes.
Okay. So I need 2184 to make a change in node 5, in the last node, right? Yes. After the while loop, okay, I should have 2184 in my temp. Then only I can make a change in this node. So let us see what is happening in this loop. So we have temp, which is 2187, okay, which is pointing to the first node, and we have previous, which is pointing to none initially, and we have data now ready to go with the while loop iteration. Okay, so data is 8. So 8 greater than temp dot data. Okay, temp dot data is what? 1, right? So condition is true. So what happens? It comes inside the while loop and starts executing the statements. So previous is equal to temp. So temp is 2187. Previous takes a copy 2187. And then the second statement is temp is equal to temp dot link. Okay. So temp is equal to temp dot link. 2187's link. What is 2187's link?
2190.
Yes, 2190. So the temp value is 2190 now. So what about, is this condition true?
No.
No, because temp is 2190, it is not equal to none, so condition is false. Again, the while loop continues, right? So data is 8, 2190's data. What is 2190's data? 3. So 8 greater than 3. Condition is true. Again, gets inside the while loop. Previous is equal to temp. Okay. Now previous takes a value 2190, and then temp is what? 2190's link. What is 2190's link?
2184.
Yes. 2184, and this condition is again false. So while loop continues. So data is 8 and 2184's data is 5. So 8 greater than 5 condition is true. Again it enters the while loop. Previous is equal to temp. So this is 2184 previous, and then we have temp. Temp is
None.
equal to temp dot link. 2184's link is none. Yes, very good. Now this condition is true, right? Temp
Yeah.
equal to none condition is true. So it breaks and comes out of the while loop. Now nn is equal to nn dot link is equal to previous dot link. So what is previous link? Previous is 2184. 2184's link is
None.
none. Should I assign it here? None. No. Yeah, correct. None. Okay. And then second step, previous dot link is equal to nn. So 2184's link is equal to nn. Nn is 2193. That's all done. Okay. So this is the first node, second node, third node, and the fourth node. Okay. Fine. That's it. Now let us write the str. Str is the same. And the main program, ll is equal to linked list. Okay, and then ll dot. So first 5 1 3 8 in this order relation set. Okay, so first 5, and then 1, and then 3, then 8. Okay, now let us display in each step and see the linked list. So print of ll. While inserting 1, self dot head is less than data. Okay, so it should be the other way, right? Greater than. Okay, so understood this, right? So if the data which I'm going to insert is less than the head, so I'll just make it in the right sense. If the data which I'm going to insert is less than the head data, okay, then I have to do this. Yeah. Okay, so first we inserted 5 only element, and then next we inserted 1, so we got 1 inserted before 5, and then 3 in between 1 and 5, and then 8 at the last position. Okay, so this is how we have to convert logic into code. It takes time, but this is how we have to do. Okay, so I think this should be helpful to write the other codes as well. Now it's already 6:07. Now let us go to the next topic. So the next topic, shall we move to the next topic, or you have any more doubts? Yes.
We can move forward.
Okay. So the next topic which you're going to see is stack. Okay. So stack we already saw while seeing functions, right? So like what example I gave you while seeing function, we have a CD tray, okay, and we keep on adding CDs on top of another, okay, and we will not be able to remove a CD from the middle. So whichever CD you added at the topmost can be removed, right? So the model for stack is last in, first out. Okay, last in, first out. Whichever element was inserted at the last should be taken at the first. Okay, so this is the basic concept behind stack. So you just imagine the CD tray. That's all. That is your stack. Now, like the various operations that can be performed on a stack are push and pop. Okay, so push function is inserting a new element. Inserting one element. Okay, one push function, one element. So here also you can see, right, in all the functions, you're inserting one element at a time. So how many elements you want to insert, those many number of function calls you have to make. Okay, so here also the same. One push function will insert one element. And similarly, the pop function, removing an element at the top position. Okay, so now let us visualize it from the Excel. Suppose is the stack. Okay, is an empty stack, and there is always a memory, not memory. There's a limit for stack. Okay, so we can just initialize. Suppose you want 5 elements to be the maximum limit, then you can ask. There will be a variable called maximum size. To that maximum size, we can assign 5, so that the number of elements will not exceed 5. Okay, so now, so initially, top would be pointing to -1. So why? Because the index starts from 0. Okay, top is like, what is this top? Yes. Okay, so top is a variable which is going to point to the index where the latest element was inserted. Okay, suppose if I insert a new element, it will be inserted at 0 position, right? So 5 elements, so index from 0 to 4. So if I insert a new element, suppose I'm inserting 5. So what would happen to top? Top will get incremented by 1, which is nothing but 0. -1 plus 1 is 0. So where the topmost element is present, right? So every time you insert a new element, you'll just increase the value of top. Okay. So next, if I insert 10, top value becomes 1. Insert one more element 15, top value becomes 2. Okay, this is all insertion operations. So what is insertion? It's nothing but push operation. Okay, pushing an element to the stack. So now if I pop an element, okay, so we cannot pop any element from anywhere else. Only the topmost element will get removed. Okay. So now what happens? I will remove the top element, and now the top becomes 1. Understood? Okay, if I remove one more element, top becomes 0. If I remove this 5 also, top becomes -1. So what does -1 denote?
No elements is present.
Stack is empty.
Yeah, no elements present, that is stack is empty. Very good. Okay, so this is a condition which we have to check before popping an element, right? So if the stack is empty, we cannot pop any element because it is no elements are there. We cannot pop, right? So before popping an element, check whether there is element or not. There are any elements or not. Okay, if there are no elements, then just put a warning message that stack is empty. So likewise, if you keep on adding new elements, 5, 10, 15, 20, 25. Now the top value is 4. Okay. So further more elements I will not be able to add because the stack is already full. Right? So what is the condition for the stack full condition? What is stack full condition?
Top
What
is
is
equals to the maximum value.
maximum value?
So
-1. Okay, so here the maximum value is 5, right? 5 elements can be added. Okay, so top is pointing to the index value, right? So top maximum will be 4, which is nothing but max size -1. Okay, if top reaches max size -1, you have to tell that
Remove.
stack overflow. Okay, stack is full like that. You have to put a warning message. Okay, so now let us look from the implementation point of view. So what all we need is we need 3 things. Okay, one is the top, other is the maximum size, which is going to be the limit. Okay, and then one storage structure. Okay, here we're going to make this of a list. So in Python, we can keep on adding more elements to the list. There is no restriction, right? We are going to impose restriction through this maximum size. So if you take other languages like C or Java, we can use array which has a fixed size, right? So we can make the arrays size is 5, okay, in other languages, right? So whereas in Python, we have list which will like keep on dynamically increasing the size. So we're going to limit the size of the stack using this maximum size. Understood? And then for like we can see that every time we add a node, okay, or we add an element at the end of the stack, right? So this is the front and this is the end, right? So which operation is equal to push? You have seen list, right? In list, we have various operations in that. Which operation is equal to push? We're always adding an element at the last.
Append.
append.
Yeah, correct. Very good. So we can simply call the append function to push a new element, right? Okay. So for popping an element,
Pop.
pop operation,
Pop.
yeah, pop is there, but what does pop do? Will it take any argument?
No, pop will only pop out the first element of the list at the 0th position
Uh,
in list.
okay, so does pop take an argument or not? No, huh? Okay.
No,
I think we can use index.
Element.
Yeah, it takes an index. Pop takes an index. Okay. So we can mention the index where we should remove. See, actually, there is one more pop item. No. Okay. So pop will take an index. Okay. We can mention the index. If you don't mention the index, by default it takes 0, I think. Let us see. Yeah. No. I think it's taking in the last. Okay. So else we can simply use pop function itself for removing an element. That is popping. Okay. Now see, like it is simply like calling the append function and the pop function. That's all. Push and pop. Now the thing is, only restriction we are going to bring in here is the maximum size. Okay, so we should not exceed the maximum size. That one condition is there. So for that, what we are going to do is like let us create a understood the concept, right? Any doubts?
So we don't have any term called peak.
Peak
Hmm.
will return the top value.
Yes, sir. We have in
Yeah,
C.
I don't think so. It is there.
Okay.
No. P A K or P?
PEEK.
No, it's not there. Okay, fine. Now let us create a stack class. Okay, so we need top, we need maximum size and a list. So def init of self comma. So top, we have the like initial value for top. Okay, and then we can create a empty list also, right? So only thing we need to pass is the maximum size. Self dot ms is equal to ms self dot top is equal to -1 because no other value comes, right? So if any other value, if there is any possibility for like if there is any possibility that top takes any other value, then we can do this default value top is equal to -1, like this we can put. But top doesn't take any other value while initializing or creating a new stack, right? So if you're creating a new stack means the stack is empty. Stack is empty means top should be -1. So there is no need for default value. Understood, right? Why I'm directly assigning it over here? Yes. And then you have the list. Okay, L or S. Okay, S for stack is equal to empty list. So even this, while creating a stack, okay, the stack is going to be empty. No elements are going to be present, right? So an empty list. If there are going to be any elements, then I can create some default value. Any doubts in this stack initialization?
So what is MS?
Maximum size.
Okay.
Okay. Now let us come to the um, init function. Sorry, not init function. Push function. Def push of. So what are the arguments that has to be passed to push?
Value.
Yes, only the value to be inserted. Okay. Self comma element. Okay. Now, before pushing, I need to check whether the stack is full, right? So what is the condition to check whether the stack is full?
Top is maximum size -1.
Top
Yes.
is equals to, yeah.
Yeah. If so, how to access top? Using self. Okay. Self dot top is
Equal
equal to,
ms -1.
yeah, again self dot ms minus 1. Print stack overflow. Else what? So we have to so we saw that append function works fine, right? For adding element at the last. So we can use append function. And after appending a new element, we should increment
Top.
top. Yeah. Okay. So self dot yes dot append of element, and then self dot top plus equal to 1. That's it, right? Okay, we have appended element and then we have incremented the top value. That's all. Now coming to the pop function. So pop function, does it take any argument?
No.
No, right? It
No.
is going to return a value which is popped, right? So self so what is the condition? We need to check before popping an element.
Top equal
Top
to
is equals
minus
to -1.
Yes. So if self dot top is equal to -1, which means that there are no elements at all, right? So I have to print a warning message, print,
Empty stack.
yeah, empty stack. And after that, see, since pop function needs to return some value, Python by default returns none, but still you can return none here. This statement, if you want to remove also, it's fine, not a problem. Okay, by default, Python, any Python function is going to return none only, but still, okay, so to make it meaningful, I return none. None means empty stack. Okay. Else, what should I do? So, is the pop function going to return the value? Let us check once. Print dot yes. So pop function is returning the value. So I can use the pop function. So now what should I do? I should decrement the value of top, right? Self dot top minus equal to 1, and then return. You can write it in two different steps, or you can write in a single step, not a problem. Okay. You can store it in a temporary variable d is equal to self dot yes dot pop, and then return d. This is also fine, or directly you can put a return statement here. Both are okay. That's all. Okay. So now let us write the main program. So stack is equal to stack of, I should pass the maximum size. Let us suppose maximum size is 3. Okay. And hello, am I audible?
Yes, sir.
Sorry, it got disconnected. Yeah. So here I'm going to write the str. In str function, we are just going to display the list. So no need to worry about that. Just put self and then you can just print self.s. That's all. Stack dot. First, let me pop and see what is the output. Okay, so print of stack dot pop, and then now let me add two, three elements. Stack dot push of 5. So after every operation, I'm just printing the stack. So next element in 15, 25. If I try to insert 25, what happens? It will throw, it should throw stack overflow warning message. Now let us see. Sorry, return. Yeah. So first it is printing empty stack, right? Why it is printing empty stack? Because I've called a pop function. Since it is empty, I am not able to pop any element, so it's printing pop, and the pop element is none. And here I'm printing the stack. It's an empty stack, so we have an empty list. And after that, I'm pushing 5. We got the element 5, and then I'm pushing 10, second element, third element 15, and fourth element I try to push. It is telling that stack overflow. Okay, now let us pop two elements. Yeah. So from this stack, I'm removing the topmost element is 15, right? So it got popped out. And then the topmost element is 10, so it also got popped out. Okay, fine. Any doubts in this? That's it about stack. I hope this should be easy, right? Are you getting too much of noise? Actually, it is raining over here.
No, sir. So
Okay. So the next topic is Q. So the concept for Q is first in, first out. Okay, so where a normal queue itself, you can take it as an example. Okay, so for example, if you stand in a queue for like booking a ticket or bus, taking a metro, okay, you stand in a queue for taking the seats, right? Okay, so taking a ticket, right? So whoever comes first will take the ticket and go first in, first out. Okay, so here also we can have a maximum size as 5, and then the index is going to be 0, 1, 2, 3, 4. So Q will have two values associated with it. So in stack we had one value, right? Top. Whereas in Q we have two values. One is the front, another is rear. Okay, front and rear. So now the front is going to point to the front element and rear is going to point to the last element. Okay. Now what should the initial values? The Q is empty, right? Initial values for front and rear.
Front equal to -1, rear equal to 0.
Why rear equal to 0?
Because it points to the last row. So no
There are,
element present, then
okay.
rear equal to 0, front equal to -1.
Okay, fine, fine, fine. See, actually, both should be initialized as -1 if they are empty because no elements are there. So if you make rear point to 0, what it means is, it means that at 0 there is an element. That's why rear is point to 0. Like that, it will be an assumption. I'll explain again. See, if you make rear point to 0, so what happens? The 0 is a valid index, right? It is one of the index in this range. It thinks that the last element is positioned at 0.
Got it, sir.
Okay, so initialize it as -1. So is the initial value. So we'll keep on adding more elements. The operations are called as NQ and DQ. NQ is adding more elements, DQ is deleting an element. Both adding one element at a time, okay? So NQ will add one element, DQ will remove one element. So if I add the first element, now what happens to front and rear?
Front will be -1 and rear will be 0.
Why front is -1? Front should point to the first element. Which is the first element?
0, 5,
5 is the first element and index of front is, so
0,
index of first element is 0. So front is 0. And rear will be pointing to the last element. Which is the last element? Again, it
0.
is 5 only, right? So the index is 0. So rear is also 0.
Okay.
And you can see that this is the only scenario where both front and rear changes. In all other cases, only either front changes or rear changes. Okay, we'll see. If I add a new element, 10. Now what happens to front and rear?
Front
Front
will be
is,
same.
front will be the same. Yeah, it is pointing to 0 only. And then rear,
1.
1. Okay, one more element, 15. rear will point to 2, right? So if I DQ an element, from where the element will get removed?
From rear,
The last.
rear.
From front it is removed.
It is a Q, right?
Yeah, first
Only
First
so
one.
5 was the first element that got inserted. So that should be the first element that should get removed. Okay. So 5 should be removed. So after removing 5, what happens is this position is vacant, right? So in Python, the index is always starting from 0 only, right? So what happens to these two elements will get shifted to this position. Understood? 5 got removed and then 10 and 15 moved one step forward. So now what happened to front? Front is the same, right? No change in the front. And what about rear?
One.
Yeah, rear will get decremented 1. Understood? So I'm adding one more element. Rear becomes 2. One more element. Rear is 3. Another element 4. If I try to add one more element, what happens? It should tell that Q is full, right? So what is the condition for Q is full?
So real should be equal to maximum size.
Yeah, maximum size -1, similar to top. Okay, so that is the condition for Q full. Okay, and if we keep on removing at one point, okay, so if we remove DQ 10, what happens? Okay, rear becomes 3. And one more DQ, 15 will get removed. Rear becomes 2. Okay, like that it goes on. Okay, let us finish this. Rear is 1. One more DQ, 15 will, 30, 25 will go away. And we have only one element, right? If we remove that also, what happens?
Front will also change.
Yes, both should be pointing to -1. So since the front value is always 0, we can just avoid the front value also. That is also okay, not a problem. Because the front value is not taking any other value other than 0, right? Or -1. So -1 means it's empty. But rear is also -1. We can use rear itself for checking whether Q is empty or Q is full, right? So front doesn't play any role over here. Okay, just for the sake of Q, we are making use of this front. Okay, you can have it or you can leave it, not a problem. Okay, but rear plays the role here. Fine. Now, like we saw like how elements are getting inserted and how elements are getting removed, right? So for NQ, which is the equivalent operation in a list? Always elements are getting added at rear position, right? So which is the operation?
Append.
Yes, very good. Append. And what about DQ?
Pop of 0.
Yeah, very good. So pop of 0. If you don't mention it as 0, what happens? The last element will get removed. Now it will start acting like a stack. Okay, you should give pop of 0. That's it. Fine. Now let us quickly implement this. def init of self comma we have friend. Okay, friend is all are, we should have only one value which is maximum size, and then self dot maximum size is equal to maximum size, self dot front is equal to -1, self dot rear is also equal to -1, and then you have a list, self dot q is equal to, or just small q is equal to empty list. Fine. Initialization is done. Def enq of, so we need to pass the data or element. Okay, so what is the condition here to check whether the queue is full? If yes, anyone?
Rare minus, I mean rare.
No,
Self dot
Max size minus 1. Self dot rare equal to max size minus.
Rear
Yeah.
is equal to ms minus.
yes, self dot ms minus 1. Okay, if this is true, then I have to print queue is full. Else I'm going to enqueue a new value, right? So I need to change both front and rear if the queue is empty. So what's the condition for queue empty? If
Equal to -1.
Rare,
yeah,
yeah,
queue
rare
dot
is
self
equals to.
dot rear or front, okay, anything you can check, is equal to -1. Okay, so which operation? Append, right? Self dot q dot append of element, and then
enter an increment.
yeah, self dot front is equal to self dot rear is equal to 0. Else okay, this can be a common step. Front equal to 0. Okay, and rear equal to rear plus 1. Understood? Or you can also write front. Okay, so if front is equal to -1, I'm just making front as 0. In no other cases, front value changes, right? Okay, and all the time, front rear value keeps on increasing. Okay, so this is NQ. Def DQ self. So if so, what's the condition for empty?
Front
Self dot front is equal to -1. Front Q is empty, and there is one more special condition. Okay, if there is only one element in the queue, both front and rear should be assigned to -1, right? So what's the condition? And return none. Return. So what's the condition to check whether there's only one element in the queue?
Front equal to rear or equal to 0.
Yeah. So we can just simply check whether rear is equal to 0, right? Self dot rear is equal to 0. Understood, right? So there's only one element. Front and rear both would be pointing to 0. Okay, we need not bother about front. Anyway, front is going to point to 0 itself. Whatever may be the number of elements, front is going to be 0 only. So rear is changing, right? So we can use rear to check whether there is only one element or not. So if there is only one element, rear would be 0. And what you have to do? You have to assign both front and rear is equal to -1. Okay, and then else if there are more elements, just decrement rear. Okay, and finally return. See, you can write your own logic. See, you need to just understand the concept. That's it. Okay, what is happening? The number of elements is differing. What is the logic? If you understand that, you can write your own logic. Okay, you can also make these two into a single condition. All those things like how we did for stack, like how we did for in this case. This also can be done. Can reduce the number of conditions. Okay. So finally, you return self dot q dot pop of 0. That's all. Okay. So def I'm writing the str method self return string of dot q. Now coming to the main program. Q is equal to q of 3. Maximum size is 3. Now let us try to deq. Q dot deq print the deq element is okay, and then print q, and then I enq few elements q dot enq of 5, and then print of q 15, 25, 35. Okay, so these three steps should work fine. This step, fourth element, right? So it should print q's full error. Okay, and let us deq few elements. Yeah. Okay, you can see the elements are being removed from the front. Okay, first 5 got removed and then 15 got removed. Once again, if you try to insert, you will get inserted at the front. Okay, 35 got inserted at the last. Fine. Any doubts in the concept? That's it for today. Do people understand?
Yes, sir.
Okay. So what about others?
Yes, sir.
Yes, sir.
Okay.
Yes.
Yeah. So you can start practicing the questions so that like then only it will register. Okay. So you can. So these are the concepts. Okay. So like you need to just like apply it. Questions will be different. You know, you might not get the same questions like just NQ or DQ. So some concept oriented questions might also be there. Okay. So you should think where to use stack and where to use queue and where to use a normal linked list and what operation to perform. Okay, all those things you should understand and then you should apply the infrastructure. Okay,
Okay, sir.
fine.
So what about the stack and queue using linked list implementation?
Stack and queue using linked list implementation. Okay.
Use implement
Uh,
using linked list. Like we need to
like
give a
yeah, yeah.
maximum is for list, but if you consider linked
For
list,
linked list, there's no maximum size, right? So now, so in linked list we had various operations, right? A
yes,
lot
sir.
of adding operations, lot of deleting operations are there. So in linked list, it takes only 2 minutes. So assuming that head is your like top or top is actually your head. Okay. So in a stack, you keep on adding elements at the last, right? So which operation is equivalent to push? Yes. Always you add at the top, right?
Yes,
Add in the beginning.
added.
Add at beginning. Okay. So every time you add an element, you add an element at the top position. You keep on adding at the top position, right? So push is nothing but add at beginning. And what about pop? From where you will remove the element?
Deleted 10.
No, no. From where you will remove the element? From the top or from the bottom?
Top.
From the top only, right? So it
Yeah,
means you are removing element from the
beginner.
head. Yeah. So deleted beginning. So if you know these two functions, then you can implement stack. That's it. Okay. And since linked list, right, there's no bound at all. You can add how many ever elements you want. And for pop alone, you'll have a you have addition. If if it is empty, then the stack is empty. That's all. And you can also do it the other way, but you tell me which is better. Okay. So push function, if you are doing append for push. Okay, so which operation is equal to pop? Yes, if you're going to use
Pop.
append for push, which
Pop.
operations? No, no, I'm asking in linked list. We had
Okay.
4 deletion operations, right? Among that, which operation?
Delete at end.
Yes. See, wherever you're pushing, from there only you have to pop, right? So you're adding at the end. Append means adding at the end. Means you have to remove from the end only, right? So delete at end.
So this is for Q or
No, and for stack only I'm telling.
okay.
Okay. So if you're using append function for push, then you have to use delete at end function for pop. If you're using add at beginning function for push, you have to use delete at the end, delete at beginning function for pop. That's it. Very simple. But among these two like scenarios, which is better with respect to
Beginning
complexity?
and end,
End is better, Why?
because we know the value of a link address there.
See, like if you're doing append function and deleted function, you need to run loops, right?
Yes, sir.
So you have to reach the last node and then you have to perform the append operation. Again, for delete at end also, you have to reach the last node and remove that element. Right? You have to write loops here. Whereas in push and pop, in add at beginning and delete at beginning. So only the first element is going to remove and add. Right? So no loops at all. With respect to complexity, so if there are 100 elements, you have to run a loop for 100 times. We should run for 100 times, right? So whereas here, that loop is not needed.
Okay.
Understood?
Yes.
So this is better than this. Okay. Both are like stack implementation only, but complexity wise, this method is better. Now coming to Q. So for NQ operation, if front is going to be considered as head. Edwin, kindly mute, no? Okay. So if front is considered as head, NQ operation, which is the equivalent operation NQ for NQ? You'll be adding at rear, right? Which means at the end. Front is head. So adding element at the end. Yes?
Yes, sir.
Sorry?
Yes, sir. Yes.
Yeah, so which operation is equivalent to NQ?
Add it and
Yes, append. DQ?
delete at begin.
Yes, very good. So if you know these two functions, you can implement Q. That's all. So if doing the other way, if NQ is considered as add at beginning, okay, what is DQ?
Delete at end.
Yes, delete at end. Okay, so in the opposite end, you have to remove, right? So if you're adding at one end, at the opposite end, you have to remove. That is Q. That's all. Okay, so if append is NQ, then delete at beginning is DQ. If add at beginning is NQ, then delete at end is DQ. That's all. Now, which is better? This one or this one?
Both are same names.
Yes, very good. Both are same. Okay, because here append requires a loop. Delete at beginning doesn't require a loop. Whereas here add at beginning doesn't require a loop. Delete at the end requires a loop. So both are same. You can implement in this way or this way. Both will do the same thing. Okay. Fine. Any doubts?
No.
For me, I had a question. Any bugs?
Sorry,
Hello.
we're not able to hear you properly.
Uh,
Your voice is
You can
loud.
hear me.
Yeah.
Okay, so yeah, I'm asking what the difference between the skill problems and the knowledge problems?
Oh, skill problems and knowledge problems. Actually, skill
Yes.
problems are practice questions. Knowledge problems, you have the last portion, right? ISS. Okay, ISS comes under knowledge position, knowledge part. Okay. So deadline
Okay.
for completion. See, actually, we need to have a meeting with the COL team. They have to decide on that. We are trying to connect with them. They are not reaching us at all. So we'll let you know. Yeah. You keep on practicing. We'll have more buffer time. Okay, no need to worry
So,
about that.
but in the website, they have mentioned that
Hmm.
before June 11th, we need to complete to get certification.
Before June 11th.
And we got a mail regarding that also, starting at the starting itself.
Okay, I'll let you know. I'm asking them for continuously every
Okay.
time, but I'm not getting any response. COL team has to respond. Okay, they're not
Okay.
responding. Okay. Okay, fine. So shall we wind up?
Yes, sir.
Yes,
So
sir.
thank you all. We can meet in the next class.
Sir, I have a problem, sir.
Yeah,
Day 3, sir. Practice problem 10.
day 3 practice problem 10.
Sir, I tried it only 60% test case pass, sir. I don't know what's wrong.
Okay, let us check. Day 3.
So practice problem 10.
Okay. How you submitted, but you know how
Yes,
much
sir.
percent?
I submitted the only 60%, sir. Test case pass.
Uh, okay, I'm not able to see where it is going wrong. Error, some mistake. Okay, you just ping me in WhatsApp now. I'll check and tell. No, it's not loading.
Okay, sir.
Okay, you just put a message to me. I'll just check and tell you. Okay. Any other doubts?
Um,
If it is submission, then you can just ping me in WhatsApp. I'll check and tell you.
so same problem, sir. I submitted problem only 87.5%. Another, sir.
Okay,
Additional problem, sir. Problem 4.
okay. No, actually, I'm not able to see the submissions. It's throwing error. I
Oh,
should check with the development team. You just ping me in WhatsApp. If there is any submission related queries, you can just ping
yes,
me in
sir.
WhatsApp. I'll check and tell.
Sir, then, sir, problem 10, sir. Additional question, problem 10, sir.
Hmm.
If you give a hint, sir, I just don't understand the question, sir.
Okay.
Mm,
well formatted list?
Yes, sir.
Uh, an input is a well formatted with respect to the labels if it follows the below condition. Input item is a list. Input item has length at least 2. Input's first item is in the list labels. Input's first item is in the list labels. Each of the remaining items in the input is either a string or a well formatted list. List label. List label actually. Okay. List label. N, which corresponds to size of the list. Okay. Next, N lines of the input corresponds to elements in the list. Next, M corresponds to size of the label. Okay. Okay, so if you see over here, if you take this entire list, how many elements are there?
Two list.
Two elements are there. Okay, VP is one
Yes, sir.
element, and then this is another list. Two elements are there. Okay, so the first condition is what? Input item has length at least 2. Okay, so there should be at
Yes,
least
sir.
2 elements in a list. Now, if you take this inner list also, you can see there are 2 elements. So this is also well formatted. Okay, and then they're telling that the first item, okay, here for this entire list, the first item is VP. Okay, so you can see VP is one of the list label. So you have the list label is also the input. So it is among the list label, right? And then this V is also among the list label. That's why it's a true over here.
Sir, first condition was input item is a list, sir. Here VP is not a list.
Input item, see this entire thing is a list, right?
Yes, sir.
They're giving one input at a time. So if there are multiple lists, multiple elements, they are giving it one item at a time. See VP one element, and then this is another element like that they're giving.
Sir,
Giving element by element. So if there are 3 elements, then they'll give 3 inputs. Okay, see here, NP is the
yes,
first
sir.
element, the
That
second
means, sir,
element.
main list has to be two, at least length two, sir. Main
Yes,
list. Oh,
yes,
this one.
yes. At
Understand,
least
sir.
2. Okay, and then you can see in the list label you have 3 elements, and we have only 2 lists. Okay, so one is NP, yes, it is there. N is also there, and the C is element is part of the main list, right? C is part of the main list, so no need to worry about the C because they're telling that at least 2, right? So there are 3 elements, so no need to worry about that. So if you see here in this one, and then here in this list there are 3 elements, and again one more list is there inside this. It is nested, right?
Yes, sir. Sir, how I'll take input, sir? Then nested list.
like this only. Only the elements of the first list will be taken. Okay, after that you need to do a string processing. So you should separate using comma, and wherever there is an open bracket, you should consider the start of the new list. Okay, just take this input and then try solving this. Okay, is this list inside a list? Okay, there is 3 nestings actually. Okay.
Yes, sir. Sir, in the example 3, sir,
Hmm.
oh, sir, sir,
Here.
question, this, example, sir, 3, sir, 4, sir, sorry, sir, 4 number, why there is false, sir?
Because in list label there is only VP, whereas here it is starting with V, right? See, this is a third condition. The inputs first item is in the list labels. Okay, so here the first item of this list is V. V is not present in this list label, so that's why it's a false. And
Then,
here,
sir, it contradicts with the first one.
yeah, here's V, right? See the list label. V is there in the list label. Here V is not there.
At least, sir, 2. I'll check at least 2, sir. First 2 elements, sir.
You should take all the list like labels. So this is the list label 1, list label 2, right? You should check
Yes, sir.
whether both the list labels are present in this list.
Then, sir, in the second example, sir, C was not in the list label.
List label is nothing but the first element only, not the third element.
Oh,
It's the third element. No need to
yes,
worry
sir,
about
yes.
it. Okay.
Understand, sir.
Okay. 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 Fine. So any other doubts, anyone? Okay. Shall we wind up?
Yes, sir.
Okay. Okay. Thank you all. We'll meet day after tomorrow.